Okay, so in this video I'm going to take you through how to find the equation of a tangent to a circle, as well as some problems as well. Now earlier on I mentioned you're going to need to know some circle theorems. In fact, you're going to need to know this specific circle theorem to help you to do this. And the circle theorem is that a tangent and a radius meet at 90 degrees. Now another way of saying meet at 90 degrees is to say that they are perpendicular. So I'm going to have a quick look at these two diagrams that we've got here. We've got a tangent. These are the tangents that we have here and here. And it says that it meets a radius at 90 degrees. So if I actually draw on a radius to this circle that we've got here, you can see how the tangent and the radius are 90 degrees. And in this second circle, the tangent and the radius are meeting at 90 degrees. So quick reminder, a tangent is a line that just touches the circle on one point. It doesn't go through the circle in two places. It just kind of skims the edge of the circle. Now this circle theorem, the fact that this radius which I've drawn in red and the tangent which I've drawn in blue, the fact that they are perpendicular to each other means that we can use some of the things we have done earlier on about straight lines and gradients and perpendicular gradients to help us to find the equation. So, find the equation of the tangent to the circle at P. Well, here are the instructions of how to find the equation of the tangent to the circle at P. We're trying to find out the equation of this line. Obviously, they will give you a coordinate of P and they will give you the equation of a circle sometimes. Sometimes they'll give you this and you'll have to work backwards. But this is what you should be doing here. You're going to start off by finding the gradient OP. Now, the gradient OP is the radius, okay? It's actually trying to find out what is the gradient of that line. And sometimes you can say this, we know that the m is the gradient. If you're finding the gradient OP, you could put the m with a little OP in the corner, or you could do an m with the r in the corner to show that you're looking for the gradient of the radius that you've got there. Remember how you find the gradient. The gradient is just the change in y over the change in x, so it'll be x2 minus x1. That's a reminder of how you find the gradient, okay? Then it wants you to find the gradient which is perpendicular to OP, because if we know the gradient of this line, I want to find out the gradient of this line that you've got here. And hopefully you can remember that to find a gradient which is perpendicular, you take the negative reciprocal of the gradient. So I'm not going to go through that in too much detail because that's for a separate video, but you find this gradient that you have and you take its negative reciprocal to find the gradient which is perpendicular. And then the last step is just to find the equation of the tangent through P, because you know what its gradient is and you know a pair of coordinates, you know x and y for this particular point that you've got here. Now there's two options. You can either use y equals mx plus c, where you'll know what m is because you've just worked it out over here with the negative reciprocal, and you know what x and y are because you get told them with this point that you have for p, and then you just need to solve that equation to find out what c is equal to. But I want to share something that is an A-level formula, which if you want to know why this formula works, I'm going to link in the video for an explanation about this formula from some of my A-level lessons. It's actually so much quicker to use because you don't always need to find out what c is. You can literally just write all of the numbers in and immediately it's an equation of a tangent. So I will show you probably both of these in one of the examples, but I'm going to lean on this one a little bit more. Of course, you can always use this one if you prefer, but when you get to A-level, you use this one so much more. So let me just quickly explain about what this is. The y and the x just stay as y and x. You don't do anything to those. But the x1 and the y1 are actually the coordinates that you are given for P. They are the x1 and y1 coordinates that you would be given. And m is just going to be the gradient that you would have found earlier on as the negative reciprocal. Okay, so let's try this with an example. We're going to use these things that we've got here with this exam style question. I've got 3 examples prepared. I'm going to do this one in one video and then the other 2 separately because I think they're perhaps a little bit trickier. Okay, so we've got that C is the circle with the equation x squared plus y squared equals 13. P is a point on C, and we can tell that P is on C because x squared plus y squared, 2 squared plus 3 squared is 4 plus 9. 4 plus 9 is equal to 13, so we know that it's a point on C, even though they've told us. And we're going to find an equation of the tangent to C at P. Well, sometimes a little sketch can just help us visualize what's going on here. So if I just do a quick set of some axes with a circle, and P is the point 2, 3. So 2, 3 is somewhere up in this first quadrant like this. There is the point P, which is 2, 3. And we're going to try and find the equation of a tangent. So that's a line that's just brushing the circle luckily I can move this line. We're going to try and find the equation of that line that is passing through like this. So the first thing that it said we were going to do is to find the radius, the gradient of the radius. There's the origin and there's P. So that's our first job, is to find the gradient OP. So the coordinate of P is 2, 3, and the coordinate of the origin is obviously 0, 0. So if I'm going to find the gradient OP, I'm going to do the change in y divided by the change in x. So 3 minus 0 divided by 2 minus 0, which is obviously just 3, 2. Now what I'm going to do is find the gradient of the perpendicular. Now the way that I show the gradient of the perpendicular is I write in the corner a little cross and I show that it's perpendicular like this. Lots of mathematicians will show that that is the gradient of the perpendicular. Now remember, to find the gradient of the perpendicular, you're going to do the negative reciprocal. So we're going to do the negative reciprocal. That means we're going to take the reciprocal of 3 over 2, which is 2 over 3, and then I'm just going to make it become negative. Obviously, if it was negative, we'd make it become positive over here. To negate means to flip it from positive to negative. So now, all that's left to do is actually just to find the equation of the tangent at P. So we're going to be using this gradient that we have, and we're going to be using this point for P that we have. We're going to be using the fact that P is 2, 3. That's all the information that we need. Now there's the two techniques. Like I said, there's the y equals mx plus c technique, which I'm going to do on the left hand side, and then we'll do the other technique on the right hand side, which I'm hoping some of you will prefer. So in this case, we know this is our value of x and this is our value of y. So I can put y is 3, m is minus 2 over 3, and x is 2. And I'm going to use that to find out what c is. So that's 3 equals minus 4 over 3 plus c. So that means that c is 3 plus 4 over 3. Well, 3 is 9 over 3. So 9 over 3 plus 4 over 3. That's going to be 9 over 3 plus 4 over 3. That is 13 over 3. Meaning the equation of the line is y equals minus 2/3 x, that's y equals mx, plus c, which we've just worked out as 13 over 3. I'm going to show you the alternative method, which is more of the A-level style. Y minus y1 equals m brackets x minus x1. Now the difference here is that our values of P are not going to be x and y, they're actually x1 and y1. The x and y here stay where they are so that you immediately will come up with the equation. So it's going to be y minus 3 equals m, which is minus 2 over 3, brackets x minus 2. Now technically, this thing that I've written here is the answer to the question. It says find an equation of the tangent. Yeah, it doesn't look like the traditional y equals, but it hasn't asked for it to look like that. So if you wrote this down, I guarantee you would still get the 3 marks in this question. You don't need to manipulate it any further unless it says write your answer in the form y equals mx plus c. So this means we actually can stop here. I'm going to keep going just to show you that you're going to get the same answer as this part down here. So if we were going to do that, what I would do is I would expand the brackets on the right hand side so that I get minus 2 over 3x, and I've got minus 2 over 3 times minus 2. Well, the negatives make it become a plus, and 2 times 2/3 is 4/3. So the last step is just to add the 3 onto the right hand side, and 4/3 plus 3, we worked it out just over there, was 13/3. So you come up with the same answer. But this one that's highlighted in yellow and this one that's highlighted in yellow are both acceptable and they would both work. So I'm just going to show you that you can put this on Desmos. I don't know if you've used Desmos much before, but just to see that it actually works, I've typed in at the top, in the red one, I've typed in the equation of the circle, and I've also typed in the equation of the tangent that we've just worked out. And you can actually see that the place where they are meeting is at the coordinates 2, 3. That part there is 2, 3. And so that must be correct. We've done everything correct about this. So if you ever want to use Desmos to kind of do it alongside your work, it really helps you sort of deepen that understanding. So I'm going to do example 2 and example 3 in the next video as they're a little bit more demanding. Found this video helpful? Then why not drop it a like and consider subscribing to my channel. If you'd like the next video in the playlist, you can click here to be taken straight to it. And as always, wishing you the very best for all your studies.